thing with a cloud application that you need to do with a traditional application. However, other things do have some changes. Application level DOS protection, you instead have things like application level request throttling or automatic scale out to defend with these things. Authentication, authorization, and audit. Many times the cloud providers will provide services that you can utilize. So for instance, there is Active Directory Federation services, Windows Live ID. There's also, for audit, there's sometimes tracing functionality. I know Windows Azure has tracing functionality where they have a audit store available to applications. For ACLs on your storage, we instead have the shared access signatures. For certificate services, storing certificates can be difficult in cloud hosting because where do you put them? You can't really put them in the, you don't really want to put them in the image for your application if it's going to be scaling out. Windows Azure provides a certificate service where when your application boots up, the platform itself installs the certificate over a secure connection. And for inter-process communication, you have things like internal endpoints and the aforementioned queue storage. So there are equivalents to the defenses and defense in-depth measures you would normally use. It's just a matter of learning what those equivalents are and making sure that your application utilizes it. Oops. So defenses inherited. When you're in a cloud hosting provider, it's not just infrastructure. With Windows Azure, especially with it being a platform as a service offering, you have not only the infrastructure things, but also things like certificate services and but many of these things would be true with any cloud hosting provider, with things like hypervisor sandboxing and load-balanced infrastructure and network-based protections against denial of service attacks, and whatever protections that they give you at the virtualization layer to protect your VMs from other VMs. So I don't have a lot of time left, but I'm going to talk briefly about design patterns for cloud applications. So one other thing that can always be used is the security development lifecycle. It's applicable to really any cloud application. When we find people inside Microsoft developing cloud applications, they usually use the SDL for Agile because they tend to be online services doing rapid releases. The Microsoft SDL site covers SDL for Agile in detail. We mandate this for any internal applications that's deploying to Azure. Obviously, it's just recommended for external customers. People can host whatever they want in a cloud provider. But we do recommend it to be used by anyone to develop more secure applications. Appropriate design patterns can take advantage of Azure runtime trust models to create hardened applications. This is talking not so much about cloud storage as if you're actually hosting your application in the cloud as well. You can isolate web roles and separate duties to individual roles to maximize use of partial trust. With a Windows Azure application, there's a locked down mode for your app, which has it run with lower privileges. And if you set your externally facing web roles to a more lockdown state, then it restricts access to the file system, registry, local environment, and so on. So a gatekeeper pattern is something like this. Your customer communicates with a web role running in partial trust, and then that web role only calls services on a worker role back behind it. And that may be through queue storage or through an authenticated web service. The important thing is it's a restricted interface. There's only some things they can send. And it is accessible only to the application. It's not available outside. Then any of your storage requests are done by this worker role. So by separating these things into a privileged backend worker role and another role which services requests from the internet, we get the same sorts of things you would get with a multi-tier application in a data center. Your backend takes inputs only via a secure channel from the gatekeeper, and it handles sanitized storage requests. Ideally, it will also do some checking, because if someone fully compromised the front-end web role, they could be sending malicious requests back through. So you've got two layers of checking. However, there's very little interface to this. All you can do is send your storage requests to it. As a result, you can only do data operations that are intended for the app. For instance, if your application only retrieves customer records one at a time and has no need for a get all customers call, there's no reason that your keymaster role needs to implement a get all customers or make arbitrary data query command at all. It may only implement get customer by customer ID. At that point, your attacker is limited in what they can carry out because they have a very small attack surface on a privileged role which has all the data keys in it. Also, they've not gotten any of the keys to your data by compromising the front-end role because the keys aren't there. In addition, if you needed to run anything with full trust, with native code execution, you could run it on this back-end role to keep the front-end role as unprivileged as possible. Now, while I've described that in the context of Windows Azure, because Azure facilitates that design pattern with the 2 trust levels, there's really no reason it would be restricted to Azure. You could implement a design like this anywhere, including Amazon Web Services, cloud, or even a non-cloud platform. The point is to separate your presentation logic from your storage logic and create a restricted boundary between these tiers. Really, it's the equivalent of the approach of making all of your database access through stored procedures and giving your application exec-only permissions. So the only things your app can do at the data layer is send precisely formatted queries that are doing the kinds of things your app does. If your app doesn't need to drop tables, there's no reason for it to have access to. If your app doesn't need to be issuing arbitrary queries, it doesn't need to have that ability. You configure least privilege on each tier. In addition, when you're threat modeling back-end tiers, do it under the assumption that the front end's already compromised. Your front end is across a trust boundary. Even though you don't mean for it to be a trust boundary, it is one. So, in conclusion, security is an important consideration in the cloud, and the work required to secure an app in cloud storage isn't really new or more technically challenging than a traditional database environment. I don't really want to convey the idea that it's more dangerous to use cloud storage. It's not necessarily. There are a lot of security features available to you if you use them. But designers and developers must consider the threats to their application and follow appropriate practices for cloud storage. And you have to use appropriate secure design and implementation patterns to counter threats that you may encounter in a cloud environment. All right, thank you.